Okay, so we got practice quiz. Where you been, buddy?
Does anyone have a pencil?
How did you start this problem, guys? Everybody's busily working.
Factor the top.
You started by factoring. And hopefully you factor the top and the bottom.
I'm working on the bottom right now.
Good deal. Okay. How did you factor the top?
Minus 2x plus 5.
Minus 2 plus 5.
2.
Does that seem
Yeah,
about
that
right
seems
to everybody? Now, what about the bottom? We can take a 2 out, and that leaves us with x squared minus x minus 2, which will factor x minus 2x plus 1. Notice I have to keep that 2. That 2 doesn't go anywhere. It stays in the problem. We're going to have a hole in our picture because we have a cancel, right? So this is now my problem. This is where I'm going to be looking from now on. But I know I have a hole at what x value?
2.
2. Because that's the factor that canceled out.
Correct.
Right? Max?
Once you plug that 2 back into the x to solve the group.
I do, because if I'm going to plot this point, I have to have a y value, right?
That's correct.
Just so I know where to put it. So I'm going to put the 2 back in this problem right here. So that's going to give me 7 over 2 times 3. So 7/6. So on my picture, I'm going to have a nice open dot at 2, 7/6. Remember, 7/6 is 1 1/6. So that's how I know where to put it. Hole.
What makes the dot open?
Because it's a hole. It is a hole. Anytime you cancel a factor out, it's going to it's a gap in the graph. Because in the original problem, it would have made 0 in the denominator. So I am indicating that it's still an excluded value. Audie?
How'd you get the 2?
It's the factor that canceled out, the x value that canceled out.
And then how did you get the 7/6? You just plugged 2 in that.
Plug 2 into that box right there.
Oh, we flipped the signs on the cancels, right?
You flip the signs every time, right?
Fair?
Think about graphing, think about synthetic division, you always do. All right, what else do I have? I need all this other stuff in my picture. What else do I need?
Why?
I need a horizontal asymptote.
Will that be provided?
What is my horizontal asymptote? Y equals 1/2. And I know it's 1/2 either by looking at the original problem, x squared over 2x squared, or by looking here, 1x over 2x. So I'm at 1/2. That's my horizontal asymptote. All right, what else do I need? Look at your list. What else do I need? I need vertical asymptotes. Where is my vertical asymptote? X equals -1. Right? Why is it x equals -1?
I'll give you 0.
Because that's what makes the denominator 0. All right, now I need my intercepts. So I need x and y. Now, they are points.
0 for x.
And if you are finding an x intercept, then the y is 0. If you are finding a y-intercept, then the x is 0. Whatever intercept you are finding, the other letter is 0. Okay? So here we go. Let's put 0 in for our x's. This says let x be 0. So if I come back to my box and put in zeros, I get 5 over 2 times 1? So I get 5 halves, which is 2.5. Now if I let y be 0, this equation equals y. So if I let y be 0, I am solving this equation. And I don't have to worry about this. It is easy. Clear the fraction. Multiply this over to here. That's a 0. What happens when you multiply something over here times 0?
0.
It's still 0. So where is your x-intercept? It is at -5. And if you were paying attention to me the other day, I told you that your x-intercept always comes from the numerator. You don't have to memorize that though, you're gonna figure it out. But if you do remember that, it always comes from the numerator. So, I have now filled in all the blanks, and I have to somehow draw a picture from this. I think we can do that, don't you?
Yeah.
These points have to be connected, and if I just kind of keep the flow going, doesn't it seem like it's going to look like that?
I think it will.
Remember, it's a version of the reciprocal function, right? Now, what about the other half of the picture? Well, we got a point right here, right?
Isn't it the same? Just
It's going to be exactly the same, just going down that way. Okay, at our meeting this morning, we were talking about how the teachers, Precal teachers, that if kids would just plot what they're supposed to, the picture becomes easy. Almost always. We looked at a hard one the other day, but they almost always do.
So the vertical asymptote would always be whatever makes the denominator 0.
Yes.
And then the x-intercept would be the what was it? The top part of the equation.
Yep. Yep, that's been written on the board several times, Ferris. All right, let's turn it over. There's one more. You have one more chance to practice. One more chance. Here we go. On the top, I'm going to take out a 3. I'm on the star side, the side with the star now. On the top, I'm going to take out a 3. Right?
Yeah.
And then that factors more. And what about the bottom? How does the bottom factor?
X plus 6.
X plus 6, X minus 3.
There's a fold. Boom. Oh, there is one.
So we've got another canceling thing. So 3x plus 3 over x plus 6 is what I'll be graphing. And there's a hole where x is 3. And I'll find the y part of the hole by plugging in 3. So 3 times 6 over 9. 2. So we have a hole at 3, 2.
Where'd you get the first 3? Is that from the top of that?
The 3
outside
came
piece.
out
Okay, on the
of the
outside.
problem in the beginning. All right, what about asymptotes?
I got x minus 6 and y 3. And then y is 3.
There's going to be a horizontal asymptote at 3. You can tell that from the beginning. You have 3x squared over 1x squared. Or you can tell it from here. You have 3x over 1x.
1.
Either way, your asymptote is at 3. Okay? Now, what about a vertical asymptote? Where is that one?
That's equal to -2.
That one's at -6. Because vertical asymptotes happen where the denominator is 0. So x equals -6 is my vertical asymptote. Now the intercepts are points, and we know one of the coordinates for the intercepts is always 0, right? Which one is 0? The one that's not the letter of the intercept you're finding. So if you're finding an x-intercept, then the y is 0. If you're finding the y-intercept, then the x is 0. So I'm going to plug 0 in for my x's. I'm going to put zeros in. So what do I get? 3 times 3 over 6. If I put zeros in. So that's 9 over 6, which reduces to 3/2, which is 1.5. So I have a y-intercept at 0, 3/2. Now, where do I get an x-intercept from? The numerator, or by setting the thing equal to 0. If you just set it equal to 0, the denominator disappears. So then you solve this, and x equals -3. So those of you that said
Where did the 3 that was outside go?
divided both sides by 3. I'm solving an equation, divide both sides by 3.
You see here why?
Now, once you get all those things filled in, you should be able to draw the picture. So all these points have to be connected, right? So it seems to me like it's going to look like this. Does that make sense to everybody?
Makes sense to me. Do we have to plot like the -3, 0? Do we have to write that next
You have
to
to
it?
label everything.
I got
Yep.
the word.
Why would you do 3x plus 3? Why would you?
Use 3x
It
plus
doesn't
6.
always have to go through the whole.
Go ahead and solve 3x plus 6.
Well, it's a whole.
Do we even try to angle into the other plane?
Plus
If
9.
there's no.
What?
Do we even try to angle that
And
into
then the
the other
whole you
plane?
got.
Oh, we need another half of the picture. We've only sketched half the picture. The other piece is kind of hidden up here. Remember, a reciprocal function has how many pieces? 2.
Even if there's no points.
Even if there's none of these, there's points up there, they're just not these important points. You have to have both
The line always has to
pieces.
go through the hole, right?
Yes. Yes. Okay?
Wait, so how do you know that? How do you know to have that up there?
What?
It's always a reciprocal, so you have to always.
It's a reciprocal function. It has 2 pieces.
You take the one you got.
Okay, now we're going to try one more by yourself before we take our minutes.
Oh no, that's what it was. Yeah, so
This
if
is
it's
another
it's like this,
practice
if you factor
problem.
it out, and then if
Try
it's
People writing it up.
Try this. This is another practice. You're trying it by yourself
it's just the 0 plus 2.
because I always make it look easy.
So like see how the whole so see how this is it's like x plus 1.
Oh, this. This is
This is another practice.
Do you want us to do both sides?
You have to say it.
Yeah.
Stay practicing, boys.
Wait, what is it? Oh, it's whatever.
Another practice.
So we just do practices for the rest of the period.
I wouldn't mind taking this.
So, start on the side where the problem is x squared plus 4x
Oh, I'm
minus
on it.
5. Start on the side that says x squared plus 4x minus 5.
Top would be x plus 5.
Tech Warriors, all right.
No, because they're not. So it's plus 1 minus.
You buy gas $1 at a time?
Then there's no.
Like someone else?
No, I'm not going by mine. I gotta do it.
This is for if you can't.
All right, let's run through this, see how far you got. You need to be able to do this all by yourselves. So here we go. How did you factor the numerator?
X minus 1, x plus 5.
X minus 1, x plus 5. I think that's right. Good. How about the denominator?
X minus 1, x minus 2.
Perfect. That's how you wanted to factor. That's exactly right. So notice, got cancellation, right? So that means we're going to have a whole. And where will the x value be for that whole? 1. And how do I find the y value?
Plug it back in.
So that would be 6 over negative 1.
Yeah. Okay, so would that make it negative like, okay, yeah.
So I'm going to have an open circle at 1, negative 6.
I got the whole
All right. Now, what about asymptotes? Remember, you are now focusing right here. Once you've canceled, you forget about all this now, and you look right here. So where are my asymptotes? What?
2 and 1.
Y equals 1. My horizontal is y equals 1. Because I have x over x, or in the original I had x squared over x squared. right? Audie?
In the whole, why would the x place not be negative?
Because it's always the opposite, Audie. Like when we graph, we always take the opposite. Okay, what about our vertical asymptote? X equals 2.
Yeah.
Because that is what would make the denominator 0. And you get vertical asymptotes by making the denominator 0. Now I need my intercepts. My intercepts. For the x-intercept, y is 0. And for the y-intercept, x is 0. So if I come over here and I put in zeros,
5 over negative.
I get 5 over negative 2. So if I put in zeros, I get 5 over negative 2, which is negative 2.5. 5 halves, 2.5. Now my equation in the box is y equals x plus 5 over x minus 2. If I let the y be 0, what's going to happen? Well, that's going to disappear. So I have 0 equals x plus 5, so my x-intercept is negative 5. And just like before, once we get all this filled in, you should have a really good sense of what this reciprocal function looks like.
Do the intercepts usually just make 1/2 of it?
It just depends. It just depends. So there we go. And then don't forget, the other side of the graph would be here. Okay, one more, and then that's it. Then we're taking a quiz. Turn it over. Turn it over. So what are you going to do to start?
Factor.
You're going to factor
We
everything.
can take a 2 out on this one.
So we can take a 2 out, okay? And when we take a 2 out of the top, we can factor it some more?
Yes. -2 plus 2.
Yep. What about the bottom? How does the bottom count?
X plus 4.
X plus 2, x plus 4. And we gotta cancel. So this is what we're left with. Be sure you write down what you're left with. That becomes the problem now you're graphing. But since we canceled out the x plus 2, we're going to have a hole at -2. Then we'll come back to our box here and we'll put in -2's.
1/3.
So 2 times -2 minus 2 over -2 plus 4. So what's -2 minus 2? -4. So my top is -8.
Yeah.
And my bottom is 2. So I think I'm at -2, -4.
Forgot to put a negative.
Got your negative. -4 on the -4.
Yeah. The horizontal slope is 2.
The horizontal asymptote is 2. Because if you look at the original problem, it's 2x squared over 1x squared.
Yeah.
But if you look at the reduced problem, it's 2x over 1x.
Vertical is 4.
vertical is what?
Negative
X equals -4, because -4 is what makes the denominator 0. And the vertical asymptote comes from where the denominator is 0. Now my intercepts are points. For the x-intercept, y will be 0, and for the y-intercept, x will be 0. If I plug in 0, I get 2 times -2 over 4. If I put in 0, so that's -1. So my y-intercept is right here, 0, -1. And if I set this thing equal to 0, to find my x-intercept, I let y be 0. Then I have 2x minus 2 equals 0 because I'm multiplying that over. If I divide both sides by 2, I still have 0. So x equals 2. Now some of you got that without doing all that work because you remembered that your x-intercept just comes from the numerator. So you didn't have to do all that work. Now I'm ready to sketch it. Okay, here we go. Obviously, these are all connected, right? So there's that one. But don't forget, how many pieces do these graphs have? At least 2, right? Depending on how many asymptotes there are. But these, every one we've done has one vertical and one horizontal. There's 2 pieces. And if that one's down there, then there's another piece up here.
Yeah.
Even though there's no points up there plotted. Lordy, we just did 4 problems after doing about 60 yesterday, so we should be ready, right?
Yes, we should.
What are you doing in your pockets?
Nothing.
Okay.